A few weeks ago, I made a video about self-hosting, basically going from nothing to a simple self-hosted setup with one Docker-based app running on your home server, exposed to the internet through the power of Traefik and Let's Encrypt. The setup we ended up with in that video basically looks like this. It's a decent start, and the way it's set up makes it easy to extend and build on top of. But it is lacking in terms of security. So in this video, I'm going to show you how to do a few things to improve the security of this setup. Specifically, here's what we're going to do. First, we'll install Authelia, an additional authentication layer that we can use to put all of our self-hosted apps behind a secure login screen with two-factor authentication. And it will also have the option to set up role-based access control to give different users different levels of access. Second, we'll set up CrowdSec, an app that will automatically ban IP addresses that are acting suspicious, and it will also ban well-known malicious IPs that it gets from a crowdsourced database. After that, we'll set up GeoBlock, which lets you ban all IPs from countries from which you don't want your self-hosted services to be accessible. And then, we'll go back to Authelia and see how we can integrate it with various self-hosted apps in a deeper way that lets us avoid having to deal with the unnecessary double authentication problem that we usually have with Authelia. And this will involve setting up another pair of apps to use as an example. Finally, we'll make use of a Docker socket-proxy, which will basically add an extra layer of security to limit the amount of damage that services like Traefik or Watchtower could do if they were to get compromised somehow. Now, before we get started, I should mention that this video is really meant to be the final part of a 3-part series, so to save time, I'm not going to repeat things that I've said before. We're basically just going to pick up right where we left off last time, and I'm going to assume that you have all the relevant background knowledge already. So if anything that I just said or showed didn't make sense to you, you will definitely want to watch the previous 2 videos first. Also, just like last time, this will be fairly fast-paced and focused on practical steps rather than conceptual explanations. And all the code will be available in the same repo linked in the description. With that out of the way, let's get started. Okay, so I've added a couple of new containers to my Docker Compose file here. Authelia actually consists of 2 containers, one for the app itself and one for the database. And this is a pretty common pattern that you'll see with a lot of apps. Most of these lines should look familiar to you, so I won't go over them in detail. We have the container name, image, user, container dependencies, etc. The Authelia container itself has a bind mount that contains some config files, and the Authelia DB has a named volume where it will store its data. Of course, just like with the other containers, Authelia has to be assigned a subdomain. In my case, that's auth.imrana.cloud, so you should make sure you've set up the DNS entries accordingly. Now, the Authelia container does have some new labels that we haven't seen before. These basically tell Traefik how to connect and work with Authelia, and that when a user is signed in, Authelia will provide the user's name, email, and other info via headers, in case any apps want to make use of that information. Not all of these lines are strictly necessary. This is just what I use, so you can look this stuff up in the Authelia documentation and decide if you want to remove any of them. Now, each container that we want to protect with Authelia needs to be configured individually. To do that, you just need to add this middleware label to each container, which I've done for File Browser and Traefik. Now, this is a good time to mention 2 things. Number 1, in the context of Traefik, things like Authelia are referred to as middleware. Middleware is anything that integrates with Traefik and does things like modify requests as they come in, or provide extra info to Traefik for decision making, etc. So Authelia and also things like CrowdSec and GeoBlock, as we'll see later, are all Traefik middleware. Number 2, you can apply middleware either on a per container basis, as I'm doing here, or to Traefik as a whole, as I'll show you how to do with CrowdSec later. But for now, I'm just going with the per container protection for this middleware. Now let's look at the config files that we'll be providing to Authelia via that bind mount. The first file is users_database.yaml, which basically defines all the users who sign into Authelia. You can add as many as you want, and you can even assign users to groups where each group will have different rules applied to them. But mine is pretty simple. I just have the one admin user. The display name is also just admin, and this password section contains a hashed version of the user's password. And you can generate this hash by running the docker command in the comment here. We also specify the user's email and assign them to one or more groups. In this case, it's just the one admin group. The other file is configuration.yaml, where all the other configuration lives. At the top, we define a secret key that Authelia will use when users sign in. Obviously, this should be something long and random that you keep hidden. A good way to generate long random strings is by using the OpenSSL command that I'm showing here. Next, I set the log level to debug for easier troubleshooting. I provide a name that will show up on the two-factor authentication app on my phone if I choose to set up 2FA. After that, I tell Authelia where to find the user's database file that we just looked at. Now, this access control section is important. It tells Authelia how we want to protect specific URLs. So what I've configured here is that if somebody tries to access files.imranar.cloud, and that person is specifically trying to access a URL that starts with share or static or public, then it should allow that request in without any kind of authentication. In other words, those URLs will not be protected by Authelia. The next rule says that everything else that is under imranar.cloud and that has not already been covered by a previous rule should be protected by Authelia, and specifically using two-factor authentication. So basically, this section tells Authelia to protect everything in imranar.cloud with two-factor authentication, except for the share, public, and static URLs for the file browser app. This way we'll be able to share files in the file browser app with other people on the internet without requiring them to sign in to Authelia. These next two sections basically just tell Authelia how to connect to the database and how to respond to suspected brute force attacks. The values I've used here are fine, except of course the session.secret and storage.encryption key values, which you should replace with your own long and random values. But for all the other lines, you can look up details in the Authelia documentation, so I'm not going to spend time on those here. The section at the bottom tells Authelia how to send notifications to users. The Authelia developers expect you to use email for this, but that's just unnecessarily complicated for my needs. So I've gone with a text file notification, which we'll see in practice in a little bit. Okay, let's see this in action. I'll run the docker compose up command, wait for the images to be downloaded and the containers to start up, then take a look at the logs, which look fine. So let's try launching the file browser app. There we go. Instead of getting access to the file browser app, I am blocked by Authelia, which is asking me to log in. I'll enter my credentials and now it wants me to set up two-factor authentication. Because remember, we specified in the config that everything requires 2FA. So I need to register a device, and it's telling me that in order to do this, I need to verify my ID using a code sent to my email. Like I said, Authelia wants you to use email for some reason, but it's not a requirement. So in this case, the verification info has just been put into a notification text file, like I defined earlier. Once I paste that in, I'm given a QR code to register a device. So I'll use the Aegis Authenticator app on my phone to scan it and enter the OTP. Now that I've set up 2FA, I can successfully sign in to File Browser. Now, what if I want to share this file in my File Browser app with somebody who is not signed in? This should be possible like I explained earlier, so let's try it out. I'll generate a share link, then try to access File Browser in an incognito window. As expected, the app itself is protected and needs a sign-in. But if I try to open the shared link, then I am able to access that and I can download the file. And that's pretty much Authelia fully set up. Next, let's set up CrowdSec. You can see there's a bunch of new lines I pasted in. Let's go over them. One thing you'll notice is that a bunch of lines are commented out, and that's because setting up CrowdSec is a multi-step process. Unfortunately, as far as I've seen, you can't just write all the code at once and run it and be done with it. So the first thing I've done here is I've added a new CrowdSec container with a couple of config files bind mounted to it, just like with Authelia, and a couple of named volumes as well. The first named volume is just for app storage, but the second is actually a volume that's going to be shared between CrowdSec and Traefik. And this is how CrowdSec will be able to access the logs from Traefik. So when Traefik receives a request, it will document that in a file in this access logs volume, and CrowdSec will then be able to read that file and use it to make decisions. Now let's look at these CrowdSec config files. The first, acquis.yaml, just tells CrowdSec where it can get information to make decisions. We've only configured one source, which is Traefik, and we're telling CrowdSec where to find the Traefik access logs, which is going to be the target of that named volume. Of course, we need to also mount the same volume in the Traefik container, as I've done here, and we need to tell Traefik to actually collect access logs and put them in a file, which is not something that it does by default. So that's what lines 137 and 138 are for. The other file, profiles.yaml, tells CrowdSec how to deal with bad IPs. Here I've told it to ban the IP for 672 hours, which is 28 days. CrowdSec is pretty powerful and you could add all sorts of rules here. For example, you could exclude specific URLs from being used in decision making, you could set up notifications to be alerted when an IP gets banned, etc. but this simple config will work for us. Before we can uncomment the rest of these lines, we need to do some manual setup. So I'll start up the new CrowdSec container, and then I can go ahead and uncomment this next part, which defines a CrowdSec-bouncer. A bouncer is basically what allows Traefik to ask CrowdSec about the decisions it has made, and whether or not a given request should be allowed in or not. In order for the bouncer to work, we need to register it with the CrowdSec container, and this requires an API key that can only be acquired from a running CrowdSec container. That's why I couldn't uncomment all these lines at once. In order to finish configuring this container, we need the previous one to already be running. Now that it is running, we need to get into it so that we can acquire that API key. You can do this with the docker exec command, so I'll run docker exec-it CrowdSec bash to open a bash shell inside of the CrowdSec container. Here I have access to the cscli command that is used to manage CrowdSec. So I'll run cscli bouncers add CrowdSec bouncer, which is the name I've given to the bouncer. It spits out an API key, which I can then paste into my bouncer container definition. Now we can uncomment this last part. This gives us a CrowdSec dashboard container, which is going to provide a nice graphical UI that shows us information about what CrowdSec is doing. Aside from the CrowdSec DB named volume, which I'll remind you should be declared at the bottom of the file like all named volumes, we have this new bind mount named CrowdSec-db, which will contain all the data needed for the app to show us information from CrowdSec. Now why do we need this? Because if you look at the image value on line 90, you'll see that this container runs an app called Metabase, which actually has nothing to do with CrowdSec. It's not developed by the CrowdSec developers. It's a totally separate app that is used to visualize info from databases. So in order for it to work with CrowdSec, it needs a ton of additional setup that would not be possible for most people to do themselves in a reasonable amount of time. So the CrowdSec developers have provided a pre-built Metabase config that we can drop into the Metabase data folder. So this is what this named volume is for, and you can download the data from the URL in the comment here. I'll go ahead and do that, and while I'm at it, I should also mention that we of course need another subdomain where this graphical UI will be accessible, so make sure to add the DNS entry for that. I'll extract the downloaded zip and place the resulting folder into the bind mount source directory. Now, unlike Authelia, which was set up for each container individually, I would like CrowdSec to apply to all containers. So instead of adding CrowdSec to the middleware label for each container, I'll add some new command parameters to the Traefik config here on line 140 instead. This way, all requests coming into the web-secure HTTPS entry point in Traefik will be subject to the decisions made by CrowdSec. So like I said before, you can decide for yourself at what level you would like various middlewares to apply, either on a per container basis or just on everything. The last thing left to do is to create a new config file for Traefik and mount it to the container as a new bind mount, as done on line 148. This config is what's called a dynamic config, and the difference between the static and dynamic configs is that the latter can be modified at any time, and Traefik will immediately pick up the changes without having to be restarted, which is pretty useful. Also, just note that the static config is basically all the stuff in the command section of the Traefik container, and it is possible to store these in their own YAML file instead of as command parameters in the Docker Compose file. It's just a matter of personal preference which method you use, so if you see static config YAML in the Traefik documentation, don't let that confuse you. For now, this dynamic config just tells Traefik where to reach the CrowdSec bouncer. The values I've used here are fine, and you can look up the documentation if you want more details. We also tell Traefik where to find the dynamic config file, here on line 139. Okay, let's start everything up. Once everything is running, I will go to crowdsec.imrana.cloud, and of course it is also protected by Authelia because I set the label for that, so I'll sign in. And here we are on the Metabase login screen. This double login stuff can be annoying, and I'll talk more about a potential solution later in the video, but for now we can use the default login credentials included by the CrowdSec developers, which are in this comment on line 90. I'll navigate to the main dashboard page, and you can see that it's totally empty for now, but that's because we just set it up, and it hasn't started receiving requests, banning IPs, etc. After a while you will see this page fill up with information. Next, let's set up GeoBlock. This is really easy. We just tell Traefik to download and install the GeoBlock plugin, specifically version 0.2.8, which I just now realized is not the latest, so you will probably want to use version 0.3.3, which is the latest at time of recording. I am way too absent-minded and forgetful to live without automatic updates, but unfortunately I don't know of a simple way to do that here. Like I said before, you can choose to apply middleware to Traefik as a whole, but in this case I would like GeoBlock to only apply to the Traefik UI dashboard itself and not, for example, to the file browser. So I'll add it to the middleware label on that specific container. Since this container already uses Authelia, there's no new label to apply. I just add a comma to the existing label and append GeoBlock to it. And I decided to also do this for the CrowdSec dashboard container. We also need to configure GeoBlock, and we do this in Traefik's dynamic config file, the same one we used for CrowdSec earlier. We don't need to go over all the new lines, but the important ones are at the bottom. On line 21, we decide whether GeoBlock should operate in blacklist or whitelist mode. In this case I'm using whitelists, so anything that's not on the list is blocked. And on the next few lines I define my whitelist. GeoBlock uses 2-letter country codes, so you should look those up if they're not obvious for your target countries, and then you can add them to the list here. You can see that when I visit the Traefik dashboard in my browser, I can access it, but if I comment Canada out of the dynamic config, Traefik immediately recognizes the change without needing to be restarted, and now if I try refreshing the Traefik dashboard page, it just tells me that access was denied. I can of course still access file browser since I didn't apply the GeoBlock middleware to that container, and if I restore my original config, I am once again able to access the Traefik dashboard. And that's all there is to it. Okay, this next step is kind of long. Remember how, for the CrowdSec dashboard, after I logged into Authelia, I still had to log in again to the Metabase app itself? And the same actually goes for the file browser app. Authelia does make things more secure, but it can cause this annoying problem for apps that have their own login system. In a lot of cases, there's just no way around this. You have to log into Authelia and then you have to log into the individual app as well. But some apps, including very popular ones like Image, do have support for OAuth, which is a way to make the app depend on an outside authentication system, such as Authelia, instead of relying on its own internal auth. This is basically how all of those sign in with Google or sign in with Apple buttons work. We can have a sign in with Authelia, at least for some apps that support it. That's what I'm going to show you how to do now. And for this demo I'll use an app called Open-WebUI, which is a web UI that you can use to talk to Ollama, which lets you run self-hosted large language models. One thing to mention is that unfortunately the way you configure OAuth will be different depending on the app you use. So you're not going to be able to just copy exactly what I've done for the Open-WebUI app and apply it to Image or some other app. Each new app you use with this will require you to dig into their documentation and probably get involved in some trial and error process before getting it to work. So for that reason, I wasn't sure whether I should even include this section in the video, but I decided to keep it. Hopefully it's still useful and does give you some general idea of how this works. So I've added the Ollama and Open-WebUI containers here, and the latter is exposed via Traefik on gpt.imranar.cloud. I'm not going to focus on the apps themselves since they're not important here. What matters is the way that you integrate them with Authelia using OAuth. Of course, the first step is to make sure Authelia is going to apply to this container, and we do that using the middleware label that we've seen before. The real magic happens here in this environment section. These variables tell the Open-WebUI app to use OAuth and tell it how to use OAuth. Like I said, each app will be configured differently, but in general, any app that uses OAuth will need to have at least the variables defined on lines 200 to 204. So let's go through those first. They may be named differently for other apps, but they will be needed. Open-WebUI in this context is an OAuth client, and all OAuth clients need a client ID and a secret that they will use to talk to the OAuth server, which in this case is Authelia. Note that if you're following along, you can leave the client secret empty for now. I'll show you how to generate one later. The client needs to know where to find the server as well as what info it can expect from the server. So that's what the next few lines are for. The other lines, 198, 199 and 205 to 208, are specific to the Open-WebUI app. They tell the app to disallow any non-OAuth logins, to use Authelia groups for role-based access control, and some actual access control rules. You can of course look up the documentation for Open-WebUI or whatever app you're using to figure out exactly what variables you need to set and how. In some cases you might need to configure OAuth through a file or through the app itself instead of through environment variables. So that was the client side of things. We still need to set up Authelia to act as an OAuth server. So in the Authelia config file, I've added a bunch of lines. I won't explain all of it because honestly I don't understand exactly how it all works myself, but this is what reading the Authelia documentation will get you. You define an identity provider and you generate two secret variables, hmaxsecret and jwks.key. And the commands to generate both of them are in the comments on lines 50 and 51. Obviously you should not use the exact values that I'm using in this video. Remember, this is YAML. So for the secret key, you have to make sure all the lines have the correct amount of indentation as you see here. Next, we configure the client. Each app that will integrate with Authelia like this will be a separate client. So in this case, we just have the one client named Open-WebUI. The client ID should be the same as what it was on the Open-WebUI side of things, and the client secret should be a hashed version of the same secret defined in the Open-WebUI config. So we can actually generate the secret and the hashed version using the command in the comment on line 84. You can see that it generates a random password, which is what you should use as the client secret in the Open-WebUI config, as well as a hashed version of that same password, which is what you should use on the Authelia side. I'm not going to explain the rest of the config in detail, because most of it is just copy-pasted from the official documentation, and for other clients you may need to tweak it based on what the documentation says for those apps. For reference and a point of comparison, I'll put my image client config up on the screen as another example. That's all we need, so I'll go ahead and start up the containers. Now when I try to launch the Open-WebUI, it immediately asks me to sign in with Authelia, and this is not actually because of any of the OAuth stuff that we just set up. This is just a plain old Authelia middleware protection, the same thing that's in place for file browser and other apps. Once we do log into Authelia, then we come to the Open-WebUI login screen. And this is where the added convenience of OAuth comes in. Instead of having to type in a second set of credentials here, I just click on Continue with Authelia and then accept the prompt and I'm signed in. So we can see that it works. So if I wanted, I could even remove the Authelia middleware label from the Open-WebUI container and it would still work in pretty much the same way, except that I would actually see the Open-WebUI screen first and then have to log into Authelia if I wasn't already. That's actually the more technically correct way to do it, but I feel that putting Authelia in front is still more secure. But there are different pros and cons for both methods. For example, with image, if you want to be able to use the image mobile app, then you will need to make sure that Authelia is only used as an OAuth server and it's not otherwise sitting in front of image. So in that case, you would have to remove it from the middleware label on the image container. So that was OAuth. You can see it's not exactly straightforward, but it's really nice once you have it set up. This next step is not really related to security, it's just something I should have put into my last video but didn't. You've seen how each container generated logs, right? And in some cases a ton of logs. By default, Docker keeps container logs around forever, so over time that can start eating into your storage space. It's not a huge problem because text doesn't really take up much space, and this would need to go on for a long time before becoming a problem. But it's still good to tell Docker to delete logs after some time, and this is what I'm doing on lines 3 to 5 here. These logging options that you see will tell Docker to limit the size of log files to 10 megabytes each, and to only keep the last 5 logs for any given container around at any given time. Now these options need to be defined separately for each and every container, which is annoying because if we ever needed to change any of the values, we would have to make the same change several times. Luckily, YAML has a really good feature called YAML anchors, which let us define YAML values only once and then reuse those values throughout the file. So that's what I've done here. I have defined an anchor called logging at the top of the file, and I've entered my values there for the size limit and log file count limit, and then I just reference that anchor in a new logging entry for each container, as you can see here. So now if I ever need to change the maximum log size, for example, I can just do it at the top and the change will apply to all the containers. So that was just a quick side thing. Let's finish the video with our last security measure, using a socket proxy for the Docker socket. Just as a reminder, the socket proxy will connect to your Docker socket and produce a second socket which has additional restrictions placed upon it. Then instead of handing access to the original Docker socket to other containers like Traefik and Watchtower, you can give them access to the second restricted socket. And this is better for security because, like I said before, the unrestricted Docker socket basically lets you do anything you want on the host system. So I've added a new container here. It's using the socket-proxy image, and we have a bunch of command parameters to configure it. The first is just telling it to print debug logs. The second line specifies what kind of GET requests clients who use this proxy should be allowed to make. It uses a regular expression to define this, and if you don't know what a regular expression is, now would be a good time to look it up. But regular expressions are basically just patterns that can be used to match and filter text. So the pattern that we're using here will allow any request for information about containers, events, and the version of Docker being used, which is exactly the information that Traefik needs in order to run. So anybody using the proxied socket would only have access to that info and would not be able to, for example, create new containers or mount volumes. The next line also allows ping requests that some apps might need. The next few lines after that just sets some default options for how the proxy should behave when something goes wrong, and the last two lines, 19 and 20, tell the proxy to make the new proxied socket available at a specific path in the container. And this path is actually the mount point for a named volume that we define in the volume section. So the restricted socket will be available through this volume, which we can then mount into the Traefik container. And of course we mount the original unrestricted Docker socket here as well. Now, like all named volumes, this one needs to be declared at the bottom of the file, but this one has some extra options being set that we haven't seen before. These options tell Docker to treat this volume as temporary, which means it only sticks around for as long as the containers that use it are around. It won't persist across restarts. Which makes sense because we're only using it to share a socket file between containers, and socket files are transient by nature. We also set some file permission options to match the permissions used by the proxy socket container. These are not strictly necessary, but they're good to have, and were copied directly from the documentation for this app. You'll notice that we actually have two new volumes, Docker proxy and Docker proxy_priv. And that's because I have a second instance of the socket proxy container. So we have two separate containers running the same software. The difference is that this second one allows clients to access more Docker functionality than the first one. Anyone who uses the proxied socket from this instance will be able to request information about containers and images, but will also be able to delete and update containers and images, which is exactly the kind of access that Watchtower needs. The rest of the new lines you see set for these socket proxy containers are just optional security enhancements like cap drop and no new privileges. I'm not going to get into detail of what these things do because you can look them up, but in general these are good to have, and the only reason I haven't applied them to all my other containers is because they do tend to break a lot of apps. So using these options requires some trial and error. In this case I know they're safe to use because they were included in the official examples. Also note that in the user section, you should replace 964 with whatever the Docker group ID is on your system, which you can find out using the command in the comment. Now let's actually make use of these new restricted sockets. I've made a few changes to my Watchtower container. First, I add a new environment variable called Docker host and point it to the location of the new restricted socket that is going to be mounted into the container. This will tell Watchtower to use that instead of looking in the default Docker socket location. And this variable is a standard thing, so it should work across all apps that require access to the Docker socket. Of course, we need to actually make sure that the path exists, so accordingly we mount the volume that we know contains the restricted socket, the same volume we attached to the socket-proxy-priv container. The :RO here just means that this has been mounted as read-only, because there's no reason Watchtower would ever need to modify the socket file. And I also added some lines to make Watchtower dependent upon the socket proxy, because obviously if the socket proxy isn't running, then it would be pointless to run Watchtower. The last thing to do is to stop giving Watchtower access to the original unrestricted socket, and this would be done by deleting the corresponding volume mount on line 70. I actually forgot to do that in the recording here on screen because of my tiny monkey brain, but you should definitely delete that line. Next, we do the same thing with Traefik, but in a slightly different way. We do mount the volume in the same way, but then instead of using that Docker host environment variable to tell Traefik where to look for the Docker socket, we use a command line parameter instead, as you can see on line 193. The reason I'm using the command line parameter instead of the environment variable is simply because that's how the official example does it. I'm pretty sure the environment variable would have worked too. And just like before, I somehow forgot to cut off access to the original unrestricted socket in the video recording here, but you should of course do that. And I'm gonna go ahead and test this out. The test is kind of pointless because I forgot to remove the original socket access, but trust me, it does work. It's just going to pull the socket proxy image, and according to the logs for the various containers, everything looks okay, so this is working. Okay, that's pretty much it. I hope this was useful, and as usual, if you want to see more random tech stuff from me in the future, you know what to do.